We're going to review some of this, talk about it. So when adding or subtracting polynomials together, we're looking for those like terms. So what like terms do you see for A? What terms? So I have 6x to the third, and I have negative 5x to the third. So if I combine these, what would I get?
1x to the third.
1x to the third. Good. What other like terms do you see?
2x and 4x.
So 2x and 4x. If I combine these, I would get 6x. Any other like terms?
No.
So if I don't have any other like terms, I can just rewrite. I can just write down whatever I have left. So that's a minus 8 in there, and then a plus 4x squared. Sorry. Is this in standard form?
No.
So in standard form, we need to write from largest values to smallest values. So I'm just going to rearrange these a little bit, just so I make sure I have the largest value, smallest value. Something that's important when we rearrange is you want to make sure you keep the sign with the number. So that negative 8, I want to keep the negative with my 8. So I need to go from highest value, or highest degree, so that's our 1x to the third. Next highest is plus 4x squared. And then I get 6x is my next highest, and then minus 8 is my lowest. Are we okay with this?
Yeah.
Yeah.
Riley, Colton, do you want to turn that off in the back, please? Thank you. So this would be your standard form. The degree of this polynomial would be 3, because that's our highest degree we have. So this would be considered, thinking back to what we learned yesterday, it would be either a cubic polynomial, or it would be a quadnomial, because we have 4. What's different about the second one? We're subtracting. So there's 2 ways you can go about this. One way is you can think, okay, it's 4 squared minus negative 5 squared, and you can think about it each like that. Another way is you can sort of just change all of these signs. Rather than making a subtraction, some people don't like subtraction problems, so I'm going to change it to a addition problem. But if I change it to an addition problem, I need to change every other sign that follows it. So that means this would have to change to an addition, this would change to a subtraction, and this would change to an addition. So if you want to, you can change the sign, but you have to change everything that follows it as well. Everything that's being subtracted will also change. You can think of that as distributing a negative 1 each of these problems. So I distribute negative 1 times negative 5 is a positive 5. Negative 1 times positive 3 is a negative 3. And then negative 1 times negative 4 is a positive 4. Then from here, once again, it's just combining those like terms. So see what like terms you have. See if you can finish this last one to combine it to figure out what are the polynomials that will end up with. What like terms do you see? 4y squared, 5y squared. So if we combine those together, we would get 9y squared. We have a 6y and a negative 3y. Combine those together, we get 3y. And then last thing we have is we have a negative 3 and a positive 4. Give us a positive 4. Is this in standard form?
Yes.
Yep, it's already in standard form. We don't have to rearrange it or anything. We're already going from highest exponents to lowest exponents. What would the degree of this polynomial be?
2.
2. That's our highest degree. So, okay. Are we okay with this stuff from yesterday? So today. Okay. You're late.
You're late.
Probably a couple carrots. All right, so yesterday we were talking about adding and subtracting polynomials. Today we're going to go one step farther and we're going to talk about multiplying polynomials. So when I have 2 polynomials and I want to multiply them together, how are we going to go about that? So we're going to start easy, and we're just going to start with monomials. So we're just going to start with single term polynomials that we're going to multiply together. Wow. So let's think about this. I have 2 monomials. I have an x and an x squared. I want to multiply these 2 monomials together. What's x times x squared? X squared.
2.
It would be x. 2x.
Yes.
X. Let's think back to last week.
That would be 1.
Yeah. Last week we talked about exponent rules. When you multiply exponents of the same base, what do we do with their exponents? We add them. So, what's the exponent of x? So we'll add 1 and 2, so that'll give us x to the third. So we'll still be using those exponent rules that we talked about last week. We can't just forget those. Typically, we're going to be using the multiplying one. We won't have to worry about our other one. So x1 times x squared. So,
Yeah, and talking about what she missed about this class.
what about x times 3x plus 1? How would we multiply this if it has two terms in that second part?
The distributed.
So we can distribute this. So it's x times 3x and x times 1. What would x times 3x be?
3x. Oh, because the x equals 1.
3x. And then if this has an x of 1, this has an x of 1, it would be 3x squared. Because we now have two x's together. What would x times 1 be? What's anything times 1? Just 1. So it would be 3x squared plus x. So just think about distributing that x into each piece. Now we're going to change a little bit. Rather than just using x, I have 2x squared that I'm multiplying by. Once again, we're going to distribute. But I have to think, okay, what is 2x squared times 4x? So our coefficients out front, I can multiply those. So that will give me 8. X squared and x to the 1 will give me x to the third. So it will be 8x to the third for that first term. Now I have to do it again. Okay, 2x squared times 7. 14. How many x's do I have? Just going to be x to the second. Because this one's really x to the 0. If you think about it, there's no x's there. And so 2 plus 0 is just x to the 2. Are we okay with this? We really just have to think about those multiplication rules that we talked about last week with exponents. When you multiply exponents in the same base, always add your exponents together. And when you're worrying about multiplying multiple things, just distribute into each piece inside of it. And we come on. Your coefficients out front, once again, will always be multiplied by each other. Boys, are you listening?
Yes.
So if I give you some problems, do you think you could try some on this?
No.
Yeah.
All right, same idea. See if you can multiply some of these together. If you get stuck, let me know. We'll talk about it in just a moment.
I don't remember it.
All right, let's talk about these. What did we find for 3x times 4x? 12x squared. Good. So once again, if we think about it, this x has an exponent of 1. This x has an exponent of 1. If it doesn't show the exponent, it's still an exponent of 1. So 3 times 4 is 12. X times x is x squared. Okay. So we distribute on the second one. What's our first term we end up with? 17y to the third, because we have a y squared and a y to the 1. Good. What about our second term? Negative 17 y to the second, because this has a y of 2. This one has no y, and so it's a y of 0. And so we just get 2 plus 0 is no 2. Are we okay with that one? Last one. How do we distribute this? So even if it has more than 2 terms, you can still distribute into every single piece inside the parentheses. Negative 12 c to the third, good. What about your second term? So it's positive 4 z to the second, good. Grab my 4. And then the last term, So negative 4 times 8 will be negative 32. And then this is a z of 0. So it would just be z to the 1. My 32 and my 0 can be the same. So we got 12, negative 12 z to the third, 4z squared minus 32z. So even if you have multiple terms, you can distribute into each of those terms with that number on the outside, with that variable on the outside. Are we okay with this? Is it coming a little bit easier now?
Yeah.
Okay. So, we've been multiplying by monomials. We've been taking a monomial and multiplying it by another polynomial. What we're going to try now is we're going to multiply two binomials together. So rather than having monomials and distributing it in, I now have a binomial term. So it's two terms in each of my polynomials. How can I multiply these together? How would I? Because I can't just distribute. Which term do I distribute in?
The x.
I just distribute the x? Like x. So when you have multiple terms that you're multiplying by, you can distribute each term both times. So the x plus 2 is getting multiplied by the x and the 1. I'm distributing the x in first, and then I'll distribute in the 1 in as well. We call this foiling. It represents first, outer, inner, last. It's not really a term you have to remember, but just remember that we're distributing. If I had 3 terms, and I wanted to distribute them, I would have to multiply all 3 of my terms by all 3 of my other terms. It is a lot of work. Typically, we only work with binomials. Multiplying binomials is a big thing. My geometry students had to do this today. So multiplying binomials is something that will keep showing up, especially in Algebra and Algebra 2. So we want to get this down specifically, but it can be used when you work with trinomials or when you work with 4 terms. You could do as many terms as you want, but it would be a lot of work. So if we look at this, I have to take x times x. So x times x is x squared, and then x times 2, 2x, 1 times x, 1x, and then 1 times 2. Do you notice anything about this? We have some like terms. So when you multiply with binomials or trinomials, sometimes you might have to combine some like terms because you're doing multiple multiplications. And so what like terms do you notice? 2x and 1x, so we can combine that to 3x. And that would be the simplified polynomial after multiplying those two. So we get x squared plus 3x plus 2. This is a quadratic. We talked about yesterday how quadratics are any polynomial with a power of 2 or a degree of 2. And quadratics will be a big thing that we're going to talk about after we talk about polynomials with this unit. That'll be the next unit we'll jump into. Are we okay with this so far?
Yeah.
How we did this? All right, let's do the second one together as well, and then I'll give you some problems to try. So I have 2x minus 1, and then x plus 5. So once again, I want to distribute each thing in to the other. So I'm going to distribute the 2x in, and I'm also going to distribute in the negative 1. So 2x times x give me 2x squared, because this has the power of 1, that has the power of 1. 2x times 5, give me 2 times 5 is 10, and then I only have a single x. Then I need to worry about the negative 1. So negative 1 times x, anything times negative 1 is just a negative version of itself. So negative 1x or negative x, whichever way you want to put it. And then negative 1 times 5, just negative 5. Once you multiply these polynomials together, these binomials, always remember to simplify. Always combine your like terms if you have it. So we have 10x and negative 1x, so I can simplify that to 9x. As long as your terms, as long as your polynomials that you're multiplying with are in standard form, your answer should also end up in standard form as well. So as long as you multiply it in that order, you shouldn't have to worry about rearranging it afterwards once you combine like terms. Are we okay with this?
Yep.
Do you want to try some?
No.
All right, let's talk about these. Dominic?
I am too.
Bradley, is that you kicking the table? Thank you. All right, so remember when we distribute, we're distributing everything into each term. So x times x, what do we get for that? X.
And yep, and then x, it's gonna be 1x.
So x times negative 6 is negative 6x. 2 times x. And then last thing, 2 times negative 6. So our like terms we have are those middle two terms we have. So negative 6 and 2x. That will be negative 6 plus 2 is negative 4x. And then, and this is your simplified polynomial. Remember, multiply each of those. Your middle terms are the ones you're typically going to have to simplify. So those middle terms are the ones we want to combine.
I just think of.
All right, on that second one, I have 2x times x. So I'll give you 2x to the second. Then I need to do 2x times 5. Give me 10x. Negative 9 times x. Negative 9x. And then negative 9 times 5. Once again, those middle terms, those are the ones that are most likely going to have to simplify together. So 10x and negative 9x will just give us a 1x. So you can write 1x or you can just write x, it doesn't matter. Do we have questions over these problems on how we do them, steps we take, rules, concerns?
Concerns one. What is the point of it?
So, Friday, our assessment is over combining polynomials. That means through addition, subtraction, or multiplication. We'll worry about adding in division of polynomials. We don't really do division of polynomials. We'll talk about dividing polynomials next week, and we'll talk about something different. We'll call it factoring. We're going to practice this tomorrow. So we're going to be practicing multiplying these binomials together, adding polynomials, writing the standard form, writing the degrees, all that stuff we talked about this week. We'll practice tomorrow. Are we okay with that?
Yes.
You already got some of the best, right?